Hello world and welcome to Fun with Electronic Soup with me, your host, John Whitmore. I've been working on a CAN bus development board. This is a PIC33 version of. I've been through a few different microcontrollers, but I think I've settled on a PIC33. So this is the third version I've done of a PIC33. I've been ironing out problems. This is a bunch of PCBs from Euro circuits. I usually get them, and I use from Euro circuits, and usually I usually hand solder, but this time, since I got for me a quite large bundle of 10 or so PCBs, I ordered up from a stencil from OSH Stencils in America. So what I get from them, apart from a nice sticker which is going on my laptop, is a solder stencil for the top and bottom. This is a two-sided PCB, so there's components on both sides. So normally when you do this, you stick this right angle. There's two little corners here that you can supply, and you'd stick them down and stick the stencil on relative to where you want things to be. Insert the PCB, put paste on, and scrape the paste over the holes, and then that's your PCB with the solder in the where it should be. But because of the two-sided nature of this board, I can't do solder one side and then turn it over, because now it's not going to lie flat, obviously. So I've decided that I'm going to create a little jig with a 3D printer and use that as the basically a jig for putting solder paste onto the board. That's the plan. So let's go to Blender. So Blender, it's an animation, open source animation package which can be used for three-dimensional designs. So I'm going to try and create the jig. When Blender starts a new project, or when it opens up, it has a camera and a light which we can both get rid of. And we want, because we're 3D printing, we want to output what we're drawing into the three-dimensional world, the real world, so it has to have dimensions. So I'm going to go with millimeters, 0.001, and type N to get up this menu. Now the jig, the stencils, there were two different sizes, not that that matters, but the larger one was 115 millimeters by 95 millimeters, say. So I wanted to make this cube, change the shape of it so that it becomes my jig. So we'll do 120 millimeters by, what did I say, 95, go 110, and then we can just make it 10 millimeters deep. And that will become the basis for the jig. So you can see the green there is the y-axis is coming straight through the middle, as is the x-axis. If we lift this up in the z-axis, position it 5 millimeters. Now our object should be just resting on top of the z, or the xy axis, so it's 0 in the z axis, which will make our algebra slightly easier. So now I want to add another cube. The way I design things in Blender so far is just adding and subtracting. So we're going to add another cube, another mesh cube. And we're going to change this to be the size of our PCB, because I want to cut a hole into this, a little cutaway that is the size of the PCB, so the PCB would just rest into the hole and be flush with the top of that jig. So The PCB is 60 millimeters, so add a bit of tolerance and go for say 60.5 by 36 millimeters, so go 36.5, and then the Z-axis will just make it 22 millimeters. It doesn't really matter, but that's, you can see there exactly what I'm trying to do is make a hole into which the PCB will just drop. Now the PCB, we want the PCB to be flush when it goes in here, to be flush with the top of this jig, like I say. So the PCB is 1.7 millimeters thick. So let's do some algebra. That's my jig at the minute. Not at the minute. That's what it's going to be. I want a little 1.7 millimeter drop. And this is 10 millimeters. So we want to drop a cube. We've just made a cube, or a box, which is the same size of a surface area on the bottom as our PCB, and it is 20 millimeters deep. So the center of this PCB box is 10 millimeters up. So everything we're working on here is in the Z-axis because and the bottom of our jig is at 0. So we have to drop that is going to be, the position of that center is going to be the 10 millimeters here plus this distance here on the Z-axis, which is the 10 minus 1.7. So that's 20 minus 1.7, so 18.3 millimeters, if my algebra is correct. So up here in the Z-axis, we're going to go to 18.3 millimeters, and that's just going to drop there. So now I'm going to select the jig, and we're going to go to this spanner, add a Boolean modifier, and I want to subtract, so the difference between the jig and our cube that we've just added, the PCB box. So if we apply that and then select our PCB and lift it out, there's our little cutaway, hopefully, so that PCB is just going to drop into that and be flush with the top of this jig, in theory. So now I want to make, I've said that it's a two-sided board and I want to be able to reverse the solder components, then reverse it and drop it back onto the jig. So I want to make another cutaway. So I'm going to reduce the size of this PCB box to be less than the size of the PCB. So 60 millimeters it was, so I'll take a millimeter off each end, so 58 millimeters in the X. 36 minus a millimeter off each end, so say 34 millimeters, and that's, oh, so now we can drop it back in, and you'll see that I'm dropping it back in, but there's a little lip around the edge of the millimeter, which the PCB will rest on, and all the components will disappear into this hole. So we want to drop this down. So back to the algebra, if I just delete that layer and add another, so at the minute we've got a little lip, I want to drop right down to create a little valley. So I've got this smaller box now to fit in here. So this is our PCB box that I've and this is the jig. So I want to leave the bottom, say 2mm. So I want to drop this PCB box in so it's 2mm. So the center of the PCB again is 10 from its bottom edge. So I obviously want that to move the center of that PCB box to be 12mm. So if I have it positioned at 12mm in the Z axis, I'm going to have it 2mm left at the bottom. So back to our Z, so we're going 12mm. And we're going to do exactly the same again. Add a Boolean modifier, and we want the difference, take that cube 1 away from the original cube, and we apply that that's pretty much what I want. So if I delete that, but the only other thing I want, there's 4 support holes in 4 mounting holes in the PCB. So I'm going to put in a little cylinder, a little pillar in each one of those 4 places to add support, so that the PCB, when it's in this jig, is resting on both the lip and 4 little pillars, the support pillars. So we're going to add a cylinder this time. Vertices I'm not too bothered about. Radius, the hole size of the PCB is 3mm. I don't want this going through, the pillars to go through, so if I make a 2mm radius, on the height 8mm, I'm not really too fussed about that. And then I've got to position it, my position, I know where the X and Y of my holes is 13.97 and 7.62. That's a bit accurate, but now I want to drop this cylinder so that its top is going to be flush with that lip. So everything's supported the same. So back to our algebra. If I delete that layer, so at the minute, the lip, big drop. So I've got 2mm at the bottom. That's 10. That's 10 minus the 1.7 of the PCB size, which is 8.3. And I want the pillar to be level with that. Now this pillar is 8mm, so this is 4. So I want this to be for those to be flush. I want 8.3 minus 4. Which is 4.3. So that 4.3. I just want to check that that's gone up to 8.3. That's at 4.3. And then we'll go 4 down. Yeah. I just want to check that my little cylinder is going to go into the base, otherwise it'll be hanging in midair, and that's not going to 3D print. So that should be good. It's not drawn to scale. Please note that's not drawn to scale. Right, so that's 4.3. So we want to select the jig again, and we're adding a Boolean modifier again, but this time we're going to do the union of the jig and the cylinder. Apply that, and now if we go back to the cylinder, and there's 4 of these in the various, so I can move it in the x-axis to the negative. So I'll just move to the other corner, back to our jig, add a Boolean, union with cylinder, apply, back to our cylinder, and we can go into the negative y for the other corner. Select the jig, Boolean modifier, union, cylinder, apply, and back into the positive x-axis for our last. So Boolean modifier, and we can now get rid of this cylinder, delete that, and that's us, I think. So to 3D print that, there's one more. I have to triangulate that, add a triangulation modifier onto that, so that it can 3D print it. So that should be good. So I'll just save that. And call it CB Mark III. And the other thing we need is I can't print that Blender file. I have to print an STL file. Well, I print an STL file. I don't know what other people print. So I'll just export that as an STL file into the same directory. And that's us. Finished with Blender. And finished with GIMP. But I do need to go to a slicer program. To take that three-dimensional object and print it, I need to slice it. So it prints just a layer at a time. So and I want to load, I've got a configuration file for my 3D printer. I've got a Prusa Mark III, the original. There's a Mark II with a fancy bed, which is a low maintenance bed. So this configuration file that I've just loaded when I started up Slicer is basically sets all the configuration of my printer. So I want to bring in the STL file I've just created and configure a few things. I'm going to print it hollow, but I'll print it 60 print 60% honeycomb. So I print 3 layers, 3 solid layers at the bottom, 3 solid layers at the top, 3 solid layers around the edges, and then I'll honeycomb the middle. So I'm not really, this isn't got to be too strong. So if I go to the layers here, that's the bottom layer. There's the solid layers, and then it's honeycombed. And it's honeycombed until there's 3 solid layers for the bottom of the hole, and then our pillar appears. And then just as the pillar, yeah, so the pillar disappears and it gets fatter at the same point where a PCB, that's where the surface where the PCB is going to be resting on, and that's where it's opening out to. And that's it. Now we can just export the G code and give that to the printer. Right, enough 3D print. Enough of that. There's enough videos on the web. So that's the result. Of our little jig. Quite happy with that. So the proof is in the pudding sort of thing. So our little PCB sits in like that, and then I can just pop it out. Hopefully I can now just attach the stencils, one on the top, one on the bottom. Something like that. But I'm not going to video my trying to stick that together, so I shall stick on my stencils, check my stock, and do some soldering. And here's the result after a bit of glue, or tape really. So the PCB stencil one side, drop it round, and stencil the other side. And that's it. So there is the result. And I soldered 2 wires on for power. I didn't solder on my 3v3 power chip. So I just tested the output from the 5V DC-DC converter. So yeah, everything seems to be working. Soldered both sides as planned and everything works. So we'll call that a success. We'll now try and power up the processors, the microcontrollers, solder in the 3v3, power up the microcontroller and see what happens. Thanks a million for watching.